Hello everyone, my name is 𝙍𝙤𝙗𝙤𝙗 and I'm 11 years old. I study in Chongzheng Primary School in Singapore. I'm quite enthusiastic to explore and learn new things. I call myself a YouTuber as I love to share my learnings through videos. I've participated and won a certificate of award last year in the same challenge, NRC RoboCup CoSpace Coding Challenge. I've also developed the app called 𝗧𝙁𝙗𝙗 as part of Swift Explorers. In 2022, I've participated and won a certificate of award in Sony Creative Science Award with Kids category. I've participated and won prizes in We Love Our Planet storytelling competitions by CDL-NLB. Here's a summary of the challenge. NRC spurs students' interest and innovation in STEM. It encourages students to develop problem-solving skills, entrepreneurial skills, creative thinking skills, and team spirit among the team members. This year's theme for NRC CoSpace Robot Challenge is Smart Transportation. In this, teams are required to complete 3 individual tasks commonly used in smart transportation, such as Navigation Challenge, Smart Sensing Challenge, and Path Planning Challenge. This is the strategy that I used. I analyzed the path to be followed, identified color combinations at different waypoints to be crossed, I identified obstacles along the path, and came up with various sensor fusions to accomplish the tasks. What is the CoSpace Auto Driving Simulator? It is powered by the CoSpace Robot Studio, and it allows programs to be developed using a graphical programming interface, GUI. How do we write CoSpace AI? Here are the steps. 1. Define the statement. 2. Set conditions. 3. Set actions. And 4. Trail run. How does the robot follow the path if it doesn't have eyes? Well, the robot uses sensors instead of eyes. There are 4 types of sensors. 1. RGB sensor. Robots use 3 color sensors to sense a color. Each one will detect the intensity of red, green, and blue light. Combining the information from the 3 sensors, the robot can conclude which color it sees. Ultrasonic sensor. Ultrasonic sensors work by emitting sound waves at a frequency too high for humans to hear. They then wait for the sound to be reflected back, calculating distance based on the time required. This is similar to how radar measures the time it takes a radio wave to return after hitting an object. IR sensors. The robot uses infrared sensors to detect and follow the path or track. Gyro sensor. Gyroscopes measure how fast it is turning. Also called a gyro, they are commonly used for navigation. By tracking how fast and which way a robot is turning, they can determine the direction your robot is facing. How do we implement lane tracking for autonomous driving? Lane tracking for autonomous driving involves several steps. 1. Sensor suite selection. 2. Lane marking detection. 3. Lane tracking. 4. Mapping and localization. 5. Control and actuation. 6. Sensor fusion. And 7. Testing and validation. How do we avoid obstacles in autonomous driving? Obstacle avoidance for autonomous driving involves detecting, responding to obstacles in the path. Here's a step-by-step approach. 1. Sensor suite selection. 2. Object detection. 3. Tracking and prediction. 4. Risk assessment. 5. Motion planning. 6. Control and actuation. And 7. Continuous monitoring. Let's see how the game actually works. Task 1 is line tracking. Now the robot is off and has reached waypoint 2 with its LED on for 1 second. We have identified the exact color code for each waypoint and set it accordingly for the RGB sensors. At every waypoint, the robot will go at a speed of 10 and its LED will be on for 1 second. Now the robot has reached waypoint 5 with its LED on for 1 second. If you have noticed, the robot is always following the line at every point of time. Do you wonder how? Well, that's because it used the IR sensors. For example, whenever it turns, it goes a bit slow because the left IR sensors recognizes the white line. So it adjusts the robot to follow the line and stay on path. The robot is now reaching its final destination, where it will stop and flash its LED for 1 second. Task 2 is obstacle avoidance. So now the robot is off and is at waypoint 2. Now it is turning in to face the wall. We have measured the exact distance between the waypoint and the wall. We set it according to the ultrasonic sensor. Once the ultrasonic sensor senses the wall, it will take a turn to the right, which will bring it out of the circle. Now the robot is reaching its waypoint, where it will flash its LED for 1 second. Like I've mentioned before, the robot uses its IR sensors to track the line to make sure that it doesn't go off path. The robot has now reached waypoint 9. It is reaching its final destination, where it will stop and flash its LED for 2 seconds. Task 3 is the open challenge. Now the robot is off and it's turning left this time, so it has reached waypoint 1. Now it's turning right into the circle. So the robot has 3 obstacles this time. Once it's reached its first obstacle, it turns left, but then it's faced with another obstacle, so it turns right. We have measured the exact distance between the robot and the obstacle. So once the ultrasonic sensor senses the wall, it will turn accordingly. Now the robot is reaching waypoint 9. The robot is reaching its final destination, where it will stop and flash its LED for 3 seconds. So how do we apply the knowledge gained from autonomous driving in the real world? To achieve sustainability through autonomous driving, we really need to focus on 1. Encouraging electric or hybrid vehicle adoption, like the blue SG cars. 2. Developing efficient routing and scheduling algorithms, like shown in the picture, which is a delivery van delivering parcels according to its schedule. And 3. Designing sustainable urban planning strategies. By prioritizing sustainability in autonomous driving development, we can create a more environmental friendly transportation system. My experiences in using AI tools. I use AI-powered language learning app Duolingo to learn French or Chinese. That's right, I'm really good at Chinese. 谢谢. I use AI-powered language learning app Grammarly for writing assistance. I use Qubit's web version for math and science, which is built using AI, which is why I'm so good in math. I also use ChatGPT for content creation and learning about new things. Thank you for watching my presentation. Bye-bye.